All right, so we're going to go over the day one problems for establishing the identities worksheet here. Hopefully this can help you if you're having some trouble with these. So first off, number one, um, just to remember kind of general process ideas here. One thing is you want to start with the more complicated side in general. That's just going to be your best bet. The second thing is oftentimes writing things in terms of sine and cosine exclusively can start to show you how certain things maybe can simplify or cancel or all kinds of things like that. And then the third thing is just keeping in mind where you're trying to go. Obviously, there are more things in that. You can look back at the notes. I have a little bit more detailed write-up, but the left side here is more complicated. I'm going to start by writing things out in terms of sine and cosine. So everything here in terms of sine and cosine using my reciprocal identities and my quotient identities, and then see what can sort of simplify and then kind of go from there. I don't know the exact path yet, and so I sort of dive into it. So I have cosine times cosecant. So that's going to be cosine theta times 1 over sine theta. Right, that's the reciprocal identity for cosecant. And then my identity here for cotangent is that it is cosine of theta over sine of theta. All right, so I'm sort of seeing what's going on here with this left-hand side. I have this expression up here, and I can kind of see what's going on. If I multiply those together, I'm going to get a cosine in the numerator, sine in the denominator, cosine in the numerator, sine in the denominator. Let's just kind of see what goes on with there. You may not know the exact path there. You may have to backtrack a few times as you're going through these, but just kind of make some progress, see what you can simplify, see if it starts to reveal itself to you. So here now I have cosine theta over sine theta. That's my numerator by multiplying these together, divided by, and then I'm not going to change that bottom right there, cosine theta over sine theta. All right, so, I mean, just take a look here. I have cosine theta over sine theta, cosine theta over sine theta. I'm dividing something by itself. Both of these could be represented instead by cotangent if I wanted to. These are both just cotangent. So I could think about it this way as cotangent theta divided by cotangent theta. I'm dividing something by itself. Algebraically speaking, this just simply simplifies to be 1, which has made this side, made the left side into the right side. I've shown that those things are algebraically equivalent to one another. There we go. Yeah, that one was a relatively easy one. All right, number 2 here, we have tangent theta times secant theta times sine theta equals tangent squared. Okay. To me, it looks like the left side is the more complicated side here. We have 3 different trig functions all multiplied together versus just tangent squared. So I'm going to work with this left side. Again, in this case, I'm going to go ahead and resort to the writing everything in terms of sine and cosine method and seeing what can simplify, what can sort of go together. So tangent is sine over cosine. That is one of our quotient identities. Times secant. Secant is 1 over cosine. That is our reciprocal identity there. Times sine, sine theta. All right, just sort of looking at it, I can combine some things together here. If I multiply all my numerators here, I end up actually with sine squared theta over cosine times cosine is cosine squared theta. All right, all right. It's really important to keep in mind where we are going. We're trying to demonstrate that this is equal to tangent squared. Sine over cosine is tangent. These are both squared. This is going to be equivalent. I'm going to show an extra step here, but this is basically done at this point. This is sine over cosine is tangent, and they're both squared. We're going to get tangent squared. But I'm going to show this real quick. I'm going to factor out the squared just as an extra step here. So I have sine theta over cosine theta squared on the outside. That would distribute into this if I wanted to apply that there. This is equal to tangent, so I end up with tangent theta squared. This is my quotient identity for tangent. Just replace tangent with it. Here we go. Tangent squared, just rewritten in a different way, right? We usually write it right there instead of out here for these parentheses. And that's our identity. We demonstrated that the left-hand side is algebraically equivalent to the right-hand side. All right, I'm gonna go ahead and clear this and move on to the next two here. So number three. All right, a little bit more complicated going on. The left side, again, for this one is more complicated. Uh, yeah, so what I'm gonna do here is I'm gonna go ahead and divide this through. So I have tangent here and then divided by tangent. So tangent theta over tangent theta plus cotangent theta over tangent theta. We'll deal with this one in a minute here. This one's a little more complicated, but this simplifies just to be 1, right? Not too bad. Here I have some things going on, right? I'm dividing cotangent divided by tangent. It's important for us to remember that cotangent is the same thing as cosine over sine. I'm going to abbreviate these things a little bit. And I'm dividing by tangent, which is, so I have cosine over sine and then sine over cosine. This is what I'm doing. I'm dividing these things. Well, instead of dividing, I can multiply by the reciprocal. So I can multiply by the reciprocal of tangent here. Well, the reciprocal of tangent is cotangent, but that's okay. That's a different thing. That's really makes this cosine over sine. So I have 1 plus cosine squared over sine squared. Cosine over sine is cotangent. I don't know why I have a plus sign right there. I have 1 plus cosine squared over sine squared. Cosine over sine is cotangent. So I can write this as 1 plus cotangent squared theta using my quotient identity for cotangent. Well, fortunately for us, this expression right here is involved in one of our Pythagorean identities. 1 plus cotangent squared theta is equal to cosecant squared. So I can simply replace this with cosecant squared theta. That is one of our Pythagorean identities, one of the forms of the Pythagorean identities. And we have demonstrated now that the left-hand side of this identity is algebraically equivalent to the right side, thus establishing the identity. All right. And our last one here, again, we're going to be using some Pythagorean identities. So looking at this problem, there are a few ways we could go about it. But the very first thing that I'm going to do here is I'm going to use a Pythagorean identity to replace this. Instead of 1 minus sine squared theta, I'm going to replace that with cosine squared theta. This is one of the forms of our first Pythagorean identity solved for cosine squared. So that is equal to cosine squared divided by cotangent squared theta. I'm not going to write this as an equation. Again, we're just manipulating the left-hand side, which is the more complicated side. All right, well, what I can do here is I can replace cotangent with its identity here, with its reciprocal identity. So I'll go ahead and do that. I have cosine squared theta divided by cosine squared theta divided by sine squared theta, right? Replace cotangent with cosine over sine. That's one of our quotient identities. I'm going to go ahead and rewrite this. So instead of dividing by this fraction, I'm going to multiply by its reciprocal. Cosine squared theta times sine squared theta over cosine squared theta. Here you can see that these cosine squareds are going to cancel, leaving us with simply sine squared theta, which is what we wanted, right? Right there. That's what we wanted. Yeah, there we go. These are one way to demonstrate these. I do want to stress right now, there are multiple pathways that we can achieve these same demonstrations that these identities are actually in fact true. There are many ways to go about it. Some ways are faster than others. These are just the ones that came to my mind quickly based on the guidelines that I gave you. Anyway, good luck guys, and I will see you in class.